graph that you have understood, right? Draw a graph S versus T to represent the motion with constant velocity. Draw this one and tell me, show me that what will be the displacement time graph that represents motion with constant velocity. If you remember the discussion of last class, I said that slope of a line or a curve drawn in S versus T, in S versus T graph, okay, slope of a line or a curve drawn in S versus T graph represents the velocity of a particle. I explained this way: velocity of a particle in its motion. Are you getting me? So velocity of a motion will be decided by the term slope of the ST graph. Is that clear? So that means, as I have said that since velocity, I have asked about the motion with constant velocity. So constant velocity means constant slope, because slope will only decide the velocity. Velocity is need to be shown as a constant in value. So velocity, to represent velocity constant in a graph, means constant slope of the graph to be drawn, isn't it? A graph is to be drawn having constant slope, isn't it or not? So having any positive value of velocity, that is to be shown in a S versus T graph. T is time, S represents displacement in y-axis. This is the origin. So if you draw it by drawing a straight line passing through origin having a certain elevation. So this elevation, why we are saying that this is something which is representing constant slope? The reason behind, if you mark various points on this graph and everywhere if you try to know the elevation, just draw a dotted line parallel to the time axis through these points, right? Just draw dotted line parallel to time axis, and then if you try to find out the angle theta by this line at different points such as A, B, C, so everywhere you will see that the theta at O will be same at every other points on this graph. Okay, so as because elevation is found to be same at everywhere throughout the graph that is representing the that has been drawn in S versus T plane, S versus T. Whenever we write down S versus something, means first one whatever is written that is shown in y-axis versus whatever that is shown in x-axis, right? That's why S versus T. S is taken on y-axis, T is taken on x-axis. So this is a straight line with a constant slope. Why constant slope? Because at everywhere on the line, the elevation of the line makes the same angle theta with actual horizontal x-axis which is representing time, or everywhere which is parallel to time axis. Okay. So since I can say, since slope of the graph, graph, that is the straight line, slope of the graph, that is the straight line, that is the straight line, slope of the graph, that is the straight line at O, A, B and C shows equal in value, shows equal in value, equal in value as tan theta remains same, tan theta remains same, means velocity of the particle, means velocity of the particle, velocity of the particle is constant. Okay. So whenever you will be said that draw a displacement time graph such that the graph can represent about the constant velocity motion, so definitely that graph will be the one which is making same angle everywhere on the line with respect to time axis or parallel to time axis. Okay. So now if I ask you to draw one graph, draw one graph of a straight line motion where particle is moving towards positive x direction, with increasing velocity, Yes, increasing velocity means acceleration is taking place. Acceleration is appearing there on the mass. But you have to draw it in S versus T graph. So, slope of S versus T graph always speaks about velocity directly, doesn't speaks about acceleration. Slope of S versus T graphs always speaks about the velocity of the particle. So, velocity increases means you have to draw the graph in such a way so that it should represent of having increasing slope continuously. Slope must be increasing continuously from one position to next position, and that is taking place continuously. It will be a curve. Yes, it will be a curve. It will be a parabolic curve bending towards displacement axis. We did this one in our last class. Okay. If this is time axis in second, this is the displacement. I can draw a graph like this, which is suppose this one, right? This one will be the graph representing the motion of a particle where velocity is continuously increasing. How can you make the argument saying that velocity is increasing continuously? If you draw tangent on the graph at various points, if you draw tangents on the graph at various points, such as this is O, this point is A, this point is B. Going from O to A, we can see the Y value increases as X value increases. So it is saying that yes, with time the particle is definitely its Y position is increasing, means it is increasing, it is showing that displacement is taking place. But along with the change of Y, along with due to the change of X, we can read one more thing, and that reading is Here you can see the theta value, theta 1, then next point it is theta 2, then another point it is theta 3. So here we can see the theta, the slope representing theta is increasing, isn't it? The slope representing tangential line is making increasing angle with the horizontal lines, right? So as we can see, we can see moving from O to A, moving from O to A on the graph, O to A on the graph, O to A on the graph. It is showing increasing exposition. It is showing increasing exposition. It is showing increasing exposition with time, and slope of the graph is also increasing, means velocity is increasing, Is that clear? So here I can see that velocity of the moving particle is increasing as the particle keeps on changing its position, that is y position representing the x-axis movement, and that is going from O to A, and further we can discuss it from A to B. There also the y position is increasing with increasing of time. Y position is increasing with increase of time, and that shows with the increasing elevation, that means velocity is increasing. So this is the one that shows that a particle is moving with increasing velocity. That is, in overall we can say there is acceleration available on the mass. There is acceleration available on the mass, right?